As our country searches for fuel alternatives to gasoline, new sources never considered before are emerging. Take, for instance, the innovative pilot project at AC Transit, a San Francisco Bay transportation provider.
Well, one thing you'll notice, it's very smooth operating, no shifting from the transmission, and very linear acceleration. So it does very well, very controllable, and has a nice ride to it.
Doug Byrne is driving one of AC Transit's fleet cars. It uses hydrogen gas as fuel, which is converted to electricity to power the car. The result? An efficient, quiet-running, non-polluting vehicle.
We average about 120 miles per day on each vehicle. Our estimation is between 45 and 50 miles per gallon. They're doing very well.
In addition, the company runs 3 hydrogen-powered buses for public transportation. The response to date from both customers and drivers has been favorable.
We have here our Kia fuel cell-powered car.
But hydrogen's biggest hurdle is the cost of its fuel cell technology. These cells that convert the gas's energy to electricity are extremely expensive. One AC Transit bus costs $1 million. Until the price point changes, hydrogen for fueling America will remain a concept rather than a solution. But even with cheaper fuel cells, one significant problem remains.
The bulk of the hydrogen is produced upon reformation of natural gas, which is reformation of methane. And as a source of hydrogen, this is fine, but it generates carbon dioxide as the byproduct, which is one of the gases that causes global warming. The other drawback, of course, is that natural gas is not going to last forever. I think our society understands nowadays that we need to generate a source of hydrogen that is renewable.
Anastasios Melas thinks the solution may be here.
This is a variety of green algae. The advantage is that they grow very fast, faster than any other plant that we know of, about 10 times faster than corn. We're talking about green power.
The single-celled algae called Chlamydomonas conducts photosynthesis just like any normal green land plant. But Melas figured out a way to trick green algae into producing hydrogen. He discovered that when the algae is deprived of sulfur and is still exposed to the sunlight, it produces an enzyme called hydrogenase. This enzyme spurs the release of hydrogen gas, and it does it in a big way.
In the lab, we get them to double their biomass every 4 or 5 hours. Under mass culture conditions, 70 to 80% of the cell volume is occupied by the chloroplast. The chloroplast is where photosynthesis takes place. So these are in fact factories of photosynthesis. That is how they are able to multiply with enormous rates. And under natural sunlight, it has been reported that they multiply or they double their biomass on a daily basis.
To test this idea and to prove that the algae could generate substantial volumes of hydrogen, Melas and his team went outside. They built a large plastic tube, known as a photobiotic reactor, filled it with 1,000 liters of water, and added the green algae with fertilizer to stimulate its growth.
Within 5 or 6 days, the medium became very dark green as the algae multiplied very quickly under the bright sunlight. And then we were able to collect bucketfuls of hydrogen. You can imagine that the 1,000-liter reactor produced 1,000 times more hydrogen than we get here in the laboratory.
CSR EES funds have allowed the University of California, Berkeley team to prove the potential of hydrogen production from algae. The challenge now is to tap its full potential, to exploit the power of green.
The problem that we have before us right now is that the yield of the process is not as high as it could be. So, for example, we know the capacity of this green algae to produce hydrogen. We find that it is only 10 to 15% of the theoretical maximum. That means that there is a lot of work for us to do. I do not know whether we will ever be able to go to the 100% level, but let's try to reach, say, 50% or 60%. And these are the hurdles that we have before us nowadays.
Once the project reaches that goal, places like AC Transit may change where they get the hydrogen from. Currently, they're involved in a joint project with Chevron Oil and produce the hydrogen on site at their Oakland, California headquarters. But beyond the world of transportation, Anastasios Melas sees his research benefiting a new kind of farmer.
I think it is a form of modified agriculture. The growth of an organism through photosynthesis, in this case, is hydrogen. It is a biofuel. It is not the traditional crop that we normally have. It's the crop of the future. I think it is absolutely essential to permit us to continue our civilization and to drive elements of our society and our economy as we know them today. We're converting the energy of sunlight into biofuel. I think it is going to help not only this country but other countries around the globe to meet their basic energy needs.
At Oregon State University, land-grant scientists are studying blue-green algae, oxygen-producing strains of cyanobacteria that also produce hydrogen.
Ethanol. As America begins to shift away from gasoline, this biofuel is becoming an early popular choice. It has a number of benefits: clean burning, high octane, and it mixes easily with gasoline, like in this E85 blend that contains 85% ethanol. While most ethanol is made from corn kernels, much of what is left behind in the field is not used to produce the biofuel. The problem is that this cellulosic material, millions of tons of stalks, husks, and cobs, doesn't chemically break down like the easily fermented yellow grain. That is, until now.
I'm Nancy Ho from Purdue University. I made a super yeast.
Nancy Ho and her team at Purdue have been modifying a yeast called Saccharomyces. This natural yeast has been used by humans for thousands of years in the making of bread and the fermentation of wine. But now, this time-tested organism is being used to break down the corn refuse, as well as wheat straw, left behind in the field. By doing this, 40% more ethanol can be produced from the same field, a real boon to farmers.
Generally, 1 dry ton residue, you can produce 85 to 100 gallons of ethanol.
While corn kernels contain glucose that can be easily fermented by conventional yeasts, the cellulosic refuse of corn has an additional natural sugar, xylose. It is xylose that prohibits fermentation and thus the making of ethanol. Nancy Ho knew that to overcome this problem, she would need to change the genetic structure of the yeast.
There's a lot of science knowing what the yeast is missing. So I simply engineer, with the recombinant technology, you can put the genes, even extra genes into the cells.
Through trial and error and CSR-EES funding, Nancy and her team found 3 perfect genes to alter the yeast. This recombinant DNA work allows both glucose and xylose sugars to be simultaneously converted to ethanol, making the process economically viable. The result? A new product called Ho Purdue yeast.
Because it can ferment both sugars very effectively, it produces ethanol very efficiently, and we still can improve it.
While the work continues at Purdue to make the Ho Purdue yeast even better, it is currently being used for ethanol production. Iogen Corporation of Ottawa, Canada, now produces the world's first cellulosic ethanol fuel for commercial use. It uses wheat straw for biomass. And American firms are also experimenting with the technology. The super yeast has the potential to change the ethanol industry, benefiting both farmers and consumers.
I feel if you work hard, you're thinking hard, you can overcome most problems in science.
The U.S. has a goal to produce 35 billion gallons of renewable alternative fuels by 2017. Today, CSR EES supports development of new feedstocks and conversion technologies for boosting renewable fuel production.
At the end of this long tunnel is a view back to the colorful past of an old frontier town.
First of all, this is a mining community. Almost every ethnic group that came to Butte, as with all other mining communities in the United States. And our population is between 90 and 100,000 people. So mining actually drove it. It was always like a huge single industry town. We're down to about 35,000 people. We still do have mining. We have about 350 people employed. And now we've gone into more diverse population as far as business is concerned. And I think that's what's really helping us go forward in a different direction, a positive direction. The real interesting thing is we're now going into more technology. And I think that's really helping us. We start to see the scientists, the engineers, and so that is really driving our economy right now.
One new high-tech employer is Resodyne, located in this historic building in downtown Butte. CSR EES awarded the company 2 SBIR, or Small Business Innovation Research grants, starting in 2002, to explore ways of converting used industrial oils and fats into diesel fuel.
Oh, it was vital. Really, without the funding, the research wouldn't have occurred. Because typically with these SBIRs, one doesn't really know how effective the research is going to be and whether it does have commercial viability. So most companies just wouldn't take that kind of risk. We had the expertise on board to tackle the problem and come up with a unique processing solution for creating biodiesel.
Steve Galbraith and senior chemical engineer Feng Zhao Yang led the team at Resodyne.
It basically makes a diesel product available out of what typically would have been a waste product. So it's recycling waste into a usable fuel. Restaurants monitor the health quality of the fats that they use for deep frying. And when the health quality gets below a certain point, they have to dispose of that. It goes through a series of stir tank reactors, and then from those reactors, there's 2 output flows. One is the glycerin, and the other flow is the B100 biodiesel fuel. And those 2 flows are separated into each constituent, and then the glycerin is purified, and the B100 is purified through a distillation process. So it's a very high quality biodiesel fuel. It's differentiated from other processes because we do run the final product through a distillation column, so it's a very clean fuel.
Today, new biodiesel plants across the country are using the processing technology developed by Resodyne. It is part of the complex solution to fueling America. And B100, if not sold in its pure form, is blended so that more vehicles can benefit from it at the pump. But back in Butte, the work still continues. In the same warehouse where the pilot refinery was built and developed, Resodyne is now experimenting with straw-to-pulp conversion. Wheat straw is a big crop in Montana. This new process, if successful, could provide the farmers here a valuable new market. They also are working with butyl, a high-octane biofuel that has a number of advantages over ethanol, including a 30% more miles per gallon benefit. The lessons learned during the B100 project helped the Resodyne staff with this new research.
From my perspective as an engineer, it certainly develops core experience in terms of designing various mechanical components such as stir tank reactors, heat exchangers, pressure vessels, piping, and whatnot. Those skills are directly transferable really to any process.
Some of the background.
Beyond that, the success generated by the SBIR grant has allowed President Larry Farrar to hire more people at Resodyne. Vital new jobs for a small western community like Butte.
He's been huge as far as economic development is concerned. Because when people look at our community, they see a success story. From 1994, starting out with 2 employees, and then going up to like 35, 40 employees right now. I believe that you'll see him going up to the 50 to 80 number in a very short period of time. I think that we're a hidden treasure here. I believe with our workforce and what we have to offer, and Larry Farrar and Resodyne is just a great example of that. It does such great things for our community and also for the United States.
Since 2002, the USDA Small Business Innovation Research Program has funded over 45 grants related to energy. Over $6.5 million was given to companies in 19 states.
Switchgrass is a perennial plant. It's planted once. It grows in place for 10 to 15 years. It grows about 6 feet tall, maybe 8. The yield is about 10 tons per acre, and that's without any genetic manipulation. It is native to the United States. It's a part of the mixed prairie grass system that used to be here. It's native from Colorado to the coast and from Alabama up to Canada.
Bert English and his colleagues at the University of Tennessee are fascinated by switchgrass because of its potential as a biomass source for ethanol production. But for most refinery operations today, corn is being used to produce ethanol. Critics argue that it might not be the best choice. As the grain's price soars due to biofuel demand, so does the cost of corn-based foods. And U.S. corn exports are also threatened due to the fast-rising prices. But beyond the economics, there is simply not enough corn to meet the energy demands of the future.
Corn has a place, but it's limited. If you look at the total energy needs of this country, corn can probably fill 16 to maybe even 18 billion gallons of ethanol, but we need 86 billion gallons or more of ethanol to come from renewable sources. And to meet that demand, we need at least 2.5 times as much corn as we grow in this nation, just for ethanol.
Scientists are now looking for other fast-growing biomass sources for fueling America, especially those that provide large amounts of cellulosic matter for ethanol production. Switchgrass fits the bill.
7'1".
This wild grass has a lot of advantages for the farmer and the environment.
You don't have to reseed it every year. You don't have to use the tractor in planting and cultivating. After the first 2 years, you probably don't have to use any chemicals on the plant. It grows and outcompetes anything in the field that's a low input, low fertilizer plant. And you can use ordinary hay equipment to harvest it.
But much needs to be learned about switchgrass for it to become a profitable, cultivatable crop. And that's what researchers are learning to do here at this University of Tennessee experiment station in Milan. Different varieties are grown under different conditions and types of terrain, from flat fields to sloped ones to semi-marshy. The color contrast here shows the effects of this experimentation.
In addition, we're looking at nitrogen tests going from 0 to 180 pounds, and we're doing some weed experiments on switchgrass to find out what herbicides will work. When you have grass growing and competing with switchgrass, it's very difficult to control that annual grass. And we're working on those types of experiments with Larry Steckel.
Soil is another major component of the study and is headed up by researcher Don Tyler. Since switchgrass is a perennial, that offers a unique advantage to the farmer.
You're not disturbing the soil for 10 or 15 years. You're adding root matter to that soil, and that's converted to organic matter. So there is some enrichment of the soil. We're trying to calculate how much of that is occurring right now in this very field.
But once these field studies are concluded, switchgrass for ethanol production still faces a number of other challenges, especially when one considers how much of it needs to be produced to meet the need.
The logistics of getting millions of acres planted into switchgrass are tremendous. You need seed, and we need reliable seed. We need seed companies looking at this and starting to develop the mechanism in which these fields that we have in the United States start producing seed for them. And we need also plant improvement. We need yield increase. The more yield per acre, the more ethanol per acre. And I think that's going to be critical as we go down the road in the long run, looking at the food versus fuel versus feed issue.
In the short run, however, things look promising for switchgrass. As part of the research, several Tennessee farmers are growing the crop on test plots on their own land, and soon they will have a market for their harvest.
Tennessee, we have a facility being planned right now that will be producing 5 million gallons of ethanol from switchgrass and from wood. By 2010 we'll have it. It won't be commercially feasible by then. By 2012 I believe it will be. We grow cellulose very well here. Having switchgrass as an alternative crop will provide the farmers another source of income and allow them to compete at a better level.
On the next edition of Partners, it's the science of small. Nanotechnology is a new science that controls atom-scale particles with astonishing results. Like micro-frameworks that promote the growth of new human skin. Nanobarcodes that expose harmful bacteria at the molecular level. Mini-trackers that reveal underground point source pollution problems. And minuscule fibrous mats that detect kitchen germs with a mere swipe of a cloth. The science of small. Next time on Partners. For more on Fueling America or other episodes of Partners Video Magazine, log on to this website.